Last time we were looking in section 14.2 at the area of circles, polygons, and we had done the polygon part, and we are at the part where we're going to look at circles and portions of circles. So let's start with that. There we go. All right, the area of a circle formula is area equals pi r squared. R, of course, is your radius. A sector is a pie-shaped section of the circle bounded by two radii and an arc. So think about a slice of cake, a slice of pizza, that's a sector. And the way that we find an area of a sector is we take basically like a proportion of the circle based upon the radius, not the radius, excuse me, the central angle, theta. So you see the angle theta marked here. I was trying to use a different one. That angle right there is a proportion of the circle. So that's where you're seeing this pi, or this theta over 360 come from. It is a portion of the whole circle, 360 degrees. Now, what you see happen in this is you see the other part of this is actually the area of the circle formula, pi r squared. And then if you combine those two components together, you get theta pi r squared over the 360. Okay? So it's always using a ratio of the whole circle's angle 360 degrees. So we're going to do two examples. One of them is a very straightforward, find the sector's area. The other one is a little bit more interesting of an application. So we have a piece of pie here, so to speak, or pizza or whatever, and we're trying to find the area of this particular sector. So our formula that we had just encountered was theta pi r squared over 360. So what is the angle theta in this particular sector? 60 degrees. And notice that it's always measured as the central arc. This one they don't show you the whole circle, but of course the rest of the circle drawn well, of course, and that was definitely not, would be over here, and this would be angle at the center. So the center is right here, right, for this to actually work. Pi is the number pi. What is r? 4. It's 4. Again, it's the radii of the circle, the radius of the circle. Make sure you've got that squared, and then divided by the 360 degrees. Now notice as you're doing that the degree markers here will in fact cancel. So the angle, or the formula, will end up giving you the area in terms of whatever the radius was, which was right here, squared. And so what was the measurement or the units on the radius in this particular problem? Centimeters. So we will get this in terms of centimeters squared because the angle measure for the degrees canceled out the unit for that. So what do we have? Grab your calculator if you would, please. You're going to take 60 times pi times 4, or you can make that a 16, divide by 360, and we'll approximate this. It will need to be an approximate because you've got pi involved, to 2 decimal places. So our standard is going to be a 2 decimal place approximation unless we're given some other directions. So if it says 3 decimals, do 3 decimals. But if it doesn't tell you, 2 decimals will be fine. Okay? So what do you get for the area of this sector? What was it?
8.3.
Is that what everyone has? Centimeters squared. All right, any questions on that one? All right, our next shape is not a simple shape. It's not a circle, it's not a polygon, it's some sort of a combination of the two things. So one of the things that that is happening I've been watching my student teachers get students ready for end of semester exams, end of year exams, state exams, these sorts of things. And pictures like these seem to be coming up a lot in the middle grades, 6th grade, 7th grade, 8th grade, okay? They are combination kind of pictures where they've taken images and they've sort of combined them together. And the simplest way to find area or the circumference or whatever it is it's asking you for is to take that image then and break it back apart. Now this one's finding the area, all right? And it's all shaded in blue. So we're going to separate it back out. into something that we can more easily find the area for. So what do you see as the ability to separate? What can we separate this into? A rectangle in the middle, and then what happens? There are two half circles on the sides. And what happens when you have two half circles? It's a whole circle. So this image is really a circle and a rectangle. Okay? So if I break it apart visually, I'll do that first. Let me get a rectangle here. The rectangle is something like this. And then I've got the semicircles here, and of course if I combine them I have a whole circle. Okay? So you know the area of a rectangle. Let's actually mark it on the pieces. You know that you need to have the length and you need to have the width. So what are the length and the width if you draw that from this original picture? Length is the easy one. What's the length?
20.
That one's 20. The width is a little trickier. 16. Okay, so Erica, I heard you first. Erica, why is it 16?
Because, you know, the radius of the circle is 8, and you have to do the diameter. Because
Okay.
it has to go all the way across.
So this piece is 8, which means that this piece is also 8, right?
Yes.
And that means that the other half on this side's 8. So does everybody see where the 16's coming from? Okay, good. Now let's take a look at finding the two area formulas. So the area of our rectangle is length times width, and we've actually got both of those pieces. The area of our circle, I almost wrote sector, circle, is what? What's that formula? Pi r squared. Do we have all of those pieces? We do. So let's do the area of the rectangle first. What is the length? What is the width? 20 times 16, and what is that if we actually multiply them? What was it? 320 meters squared. Good. Square units because we're working with area. All right, let's do the area of the circle pi. What's the radius? 8. And then we're squaring it. So before we multiply by pi, it's 64 pi, right? Okay, so what is 64 pi? We'll use 2 decimals just because there's nothing else told to us. 2 decimals of accuracy. So it is an approximation. 201.06 meters squared. So our total area is what? 521.06 meters squared. Okay, any questions on that one? All right.